Going to be doing the rest of chapter 9, so I'm just going to give you links to these videos since we're not meeting in class today. 9.5 is negative and zero exponents. So we've talked about positive exponents and done a little bit. We'll review a tiny bit and then talk some more. So first we have x to the fifth over x to the third. If you remember, x to the fifth over x to the third, when I have division, I subtract the exponents. So since I have the 5 on top and the 3 on bottom, it's x to the 5 minus 3, whoops, and 5 minus 3 is 2, so that's x squared. But what happens if the denominator is bigger? So I have x to the fourth divided by x to the seventh. If I follow the rules of exponents, that would be x to the 4 minus 7. Now 4 minus 7 is negative 3, so that's x to the negative 3 power. But the question is, what does that mean exactly? What happens? What does that mean when I have a negative exponent? So let's break this down. X to the fourth over x to the seventh. Let's use what we know about exponents. X to the fourth means x times x times x times x. On the bottom, and on the top I have 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I can group them. Remember how we talked about last week, if I have any number divided by itself, that equals 1. So let's just add a times 1 here, and then we'll kind of group this. We'll take these 4 x's. Since it's multiplication and division, I can split it up, right? I can change the order and anything else because it's commutative, it's associative, and all that. So I have x times x times x, 1, 2, 3, 4 x's times 4 x's, which is 1. And then I'm left with, on the top, 1, and then 3 more x's on the bottom. So that 1 doesn't really matter. 1 over x times, whoops, sorry, don't have my camera in the right place. X times x is x to the third, so that's 1 over x to the third. So what that means is my x to the negative 3 and this 1 over x to the third must be the same, right? I got that from just working it 2 different ways. So x to the negative 3 is equal to 1 over x to the third. So definition of negative exponents for any non-zero number x, take a second to think about why would x have to be non-zero. And if you think about it, look up here. If x is 0, I'm dividing by 0, right? I've got x to the 7th on the bottom, and I can't divide by 0. So that's why any non-zero number x, and for any integer n, x to the negative n is equal to 1 divided by x to the n. Okay, so this is the definition. You'll find it in a blue box in your book. I'm trying to get that to focus there. So this is the definition of negative exponents. So what that means is if I have x to the negative 2, that's going to equal 1 over x squared. Hope that makes sense to you. Okay, so a negative exponent just means that it's in the denominator. For this chapter, actually, the questions are asking you to not have fractions, so you're going to express this as a negative exponent instead, and we'll show that in the examples. So the next thing we're talking about is a zero exponent. So let's look, what if I have x to the fifth over x to the fifth? We already know that any number divided by itself is 1, right? Although, let's not write that right now. Let's use what we know about exponents. That would mean then that I need to subtract the denominator from the numerator, right? If I'm going back to my rules of exponents, x to the fifth over x to the third is equal to x to the 5 minus 3. So x to the fifth over x to the fifth is equal to x to the 5 minus 5. And 5 minus 5 is 0. So x to the fifth over x to the fifth is equal to x to the 0, and that also, as we know, any number divided by itself is 1. So here is our definition of zero exponents. Any number, non-zero number, to the 0 power is equal to 1. Okay, so let's just do some examples from the book. First one, x to the 5th over x to the 7th. This is very similar to the one we just did. So I just go x to the 5 minus 7 equals, and x to the 5 minus 7 is negative 2. So x to the 5th over x to the 7th is equal to x to the negative 2 power. Here I have a negative exponent already, but I'm just going to use the rules of exponents that we learned last week. So if I have r to the negative 3 divided by r to the 4th, that's r to the negative 3, that's the numerator exponent, minus, and 4 is what's on the bottom. So negative 3 minus 4 is equal to r to the negative 7. Next one, we have x to the 7th times x to the 4th. So if you remember what we do when we multiply exponents, we add, or when we multiply powers with the same base, we add their exponents. So x is my base. I have x to the negative 7 times x to the 4th, so that's going to be x to the negative 7 plus 4. So you just need to watch your negatives and positives here. So negative 7 plus 4 is equal to negative 3. So I get x to the negative 3. The next one, we have a power to a power. If you need to review these rules from last week, they're all in blue boxes in the previous section. So x 3 times x to the negative 5 all squared. So first thing you need to know, when you have a power, you take each part of each thing that's multiplied to that power. So that's going to be 3 squared times x to the negative 5 squared. Okay, so 3 squared is 9. And then x to the negative 5 squared, if I have a power to a power, I multiply the exponents. So again, you need to pay attention to the negative. So I have x as my base, and then I've got negative 5 times 2 equals negative 10. So negative 9 times x to the negative 10. The next one we're going to have to deal with in kind of two parts, right? The first one, x to the 7th and y to the 5th. I'll just write that. I don't really have to do much with that at the start. Let's talk about this x to the 3rd divided by y all to the negative 2 power. So I'm just going to take each part to the negative 2 power. So x to the 3rd to the negative 2 power means I'm going to take 3 times negative 2, which is x to the negative 6. And then y is just y, so that's going to be divided by y to the negative 2 power. So I just took, this is y to the 1st power, remember. So 1 times negative 2 is negative 2. Oops. I wrote x to the 5th on the bottom here instead of y. So let's, whoops. Didn't erase that very well, but good enough. Okay. So now, I'm going to just combine the variables that are alike, right? These x's are both the same. So on the top I have x to the 7th times x to the negative 6. When I multiply, when you multiply fractions, you multiply across the top, you multiply across the bottom. So x to the 7th times x to the negative 6 is going to be x to the 7 plus negative 6, or 7 minus 6 on the top. And here I have y to the 5th times y to the negative 2, so that's y to the 5 minus 2. I'm going to bring this down. Oh, sorry. I keep moving the camera. Okay. 7 minus 6 is 1, so that's going to be x, divided by y to the 5 minus 2 is y to the 3rd. And in this chapter, they seem to not want fractions, so they want us to take this y to the 3rd in the denominator and move it up to the top. And we know, going back to our definition, if I have x to the 3rd in the denominator, then to move it up to the numerator, I just need to make that exponent negative. So x divided by y to the 3rd is going to be the same as x times y to the negative 3. And that's my answer. So your assignment for this is 1 through 109, every other odd. Just make sure you do every other odd, and it's not that many problems. Okay, that's all. We'll move on to the next one now.